From Magny State Park and Devil's Kettle, we're now going to take a quick trip up the shore toward Grand Portage, where the French voyageurs had their trading post. We're getting close to the border now. We're in Grand Portage, Minnesota now, just south of the border. This is the Grand Portage National Monument, the old French fur post. Our objective today is to expose the vulnerabilities of public data members. We'll learn how to use data hiding to prevent data members from unwanted changes. And we'll learn how to code accessor functions and mutator functions to give us access to and allow us to change those hidden variables. So let's start out with this example. Imagine you've got a Fitbit, and it keeps track of your distance that you've run, how long it took you, and can calculate your miles per hour. The mileage class definition would be perfect for this. So in the main program, we make a mileage object called myRun. We enter the distance, we enter the time, and we tell the myRun object to calculate its miles per hour. And then we print those three things out. Everything works great as long as we enter good data. You can see at the top, we say that we ran 6 miles in 43 minutes, and it prints out our miles per hour. But now look at this example. If I enter a negative value for miles, I get a negative miles per hour. If I enter a negative amount for minutes, I get a negative miles per hour. This is clearly garbage in and garbage out. And the whole problem is that I was able to enter bad data directly into the data members of the class. We can fix this by locking those away in private. Private data members cannot be altered by the client, and so they're safe. Of course, the only problem is now our program doesn't compile because we try to read data into distance and time, and that's not allowed. Those are private. So what are we going to do? This is a solution. We create a set of functions called accessors and mutators. Accessors allow us to access private data members, and mutators allow us to change private data members. This is pretty much the lesson of this entire video, so let's spend some time looking at the code. For the accessors, all they do is tell you what's in a particular data member, distance, time, or miles per hour. They return it. And the mutators take a parameter and plug it in to the private data member. That enables the change. Okay, so now we've revised the main program. We've called our mutators setDistance and setTime to plug in the distance and the minutes. In the upper right, you see the result of the run, 6 miles, 52 minutes, and it works great. Now what if we enter bad data? -5 for miles. Unfortunately, we still get bad results. The same thing for minutes of 0. So the fact that we have a mutator that just takes whatever we give it and dumps it in hasn't really changed things much. We really need to do more here. We're going to make these mutators more robust. I've prototyped them now in the class definition because we're going to write more code for each of them. And here they are outside of the class definition, setDistance and setTime, and in both cases they take the parameter and evaluate it to see if it's any good. If it's greater than or equal to 0, it's a valid distance. If it's greater than 0, it's a valid time. And if the data is invalid, we get an error message that says invalid distance or invalid minutes. In action, the program now looks like this. You can see down below we've entered a miles of -6 and minutes of 0, and it flagged both of them as invalid. That's great. That's the good news. But the bad news is that the garbage ends up being used to calculate some bogus result. -NaN means not a number. So we need to go back to our design and take a look at it. The main program makes sense. we read a distance and we set it, minutes and we set it. But we have to evaluate these before we go ahead to do the calculations. And we can do that with an if statement. Remember, we have accessor functions too, so we can tell the myRun object to get the time, get the distance, and if they're good, and only if they're good, to go ahead and process the data. Otherwise, print out an error message. This is a good way to handle things. But we could make a change that would be even better. Back to the mutators. Instead of void, let's change their return type to Boolean, and they can tell us, true or false, whether the data was any good. So if the distance is greater than or equal to 0, we plug it in and return true. Otherwise, we print an error message and return false. Set distance and set time are both now member functions that return a Boolean value once they've done their job. We can use these Boolean values, plugging them into Boolean variables. Here we have distance OK and minutes OK declared at the top. We set true or false into them depending upon how the mutator runs, and then we check them out with the if statement. If dist OK is true and minutes OK is true, then we can calculate the miles per hour. Otherwise, we print an error message. And in action, you can see that this works. Good data gets processed correctly, and bad data gets flagged with an error message, and then the program ends. So what have we done today? We started with a class definition that allowed the user to enter invalid data and produced invalid results. Then we added a private designator to establish data hiding. These modifications meant that the main program could not access the data members directly, so instead we produced mutators and accessors. Mutator functions allow the client code, the main program, to make changes, and accessor functions allow the client to see what's in those private data members. Mutators and accessors are critically important tools in modern object-oriented programming. Thanks for watching.